Ever wondered how a robot knows exactly which blocks to stack? Or how an AI system avoids conflicting commands when solving a puzzle? It's not just about code, it's about smart planning with knowledge. Today, we're unpacking a groundbreaking study that's making AI planning faster, smarter, and more reliable. Let's dive in. Planning systems are the brains behind automation. Imagine a robot organizing a warehouse. It must figure out the best way to move boxes, avoid collisions, and follow rules like don't stack heavy items on fragile ones. But here's the catch. The robot also needs to understand the world. That's where ontologies come in, digital dictionaries that define relationships between concepts. For example, a box is an object, and an object can be heavy or fragile. But how do you teach a machine to use this knowledge effectively? The researchers tested their ideas on classic AI challenges, like the blocks problem, stacking blocks, and cats and robot scenarios. They even tweaked these benchmarks with coherence rules to stop the AI from making impossible moves, like trying to both add and remove the same block at once. It's like giving the system a cheat sheet to avoid contradictions. Now here's where the tech gets cool. They built on an existing tool called eKAB, which handles knowledge-based planning, and upgraded it to ceKAB. The trick? Translating complex logic into a format that planning algorithms can digest. They used a tool called Clipper to simplify rules, and a data log engine named Nemo to pre-calculate all possible conclusions. Think of it as letting the AI do the heavy thinking up front, so it can focus on the actual task without getting stuck in endless what-ifs. The experiments? Wildly successful. When they pitted ceKAB against older methods like GBFS, it outperformed them, especially when paired with a technique called Tseitin transformation. What's that? Imagine simplifying a tangled mess of wires into clean, organized circuits. This method streamlines logical formulas, letting the AI work faster. The result? Fewer steps, less time, and way fewer errors. But why does this matter? Let's break it down. Traditional planning systems operate under closed-world semantics, assuming only explicitly stated facts are true. If a block isn't listed as on a table, the robot thinks it's not there. But the real world is messy. Enter ontologies, structured frameworks that define relationships, like if a block has another block on top, it's blocked. These use open-world semantics, where unknown facts aren't assumed false. The problem? Classical planning doesn't play well with open-world logic. It's like trying to fit a square peg in a round hole. The researchers solved this with ceKAB, coherent eKABs, a system that bridges these worlds. They use DL-lite ontologies, a lightweight type of ontology, to encode background knowledge. But how do you make sure actions respect both explicit facts and implicit truths? Enter coherence update semantics. Let's say the robot tries to move a block. Traditional systems check only physical possibilities, ignoring hidden rules. With this new method, the system automatically adjusts for implicit knowledge. For example, if moving a block would make another unblocked, the state updates without programming every edge case. This isn't just theoretical. The team compiled their logic into PDDL, the standard language for planning systems, and tested it on benchmarks. The result? A system as efficient as traditional methods, but smarter about the world. Imagine an AI assistant organizing a warehouse. It could use ontologies to understand that a forklift can only lift heavy items, or items on a shelf are accessible. By integrating this knowledge, the AI avoids silly mistakes, like trying to move a block that's actually stuck under another. So what's the takeaway? This research isn't just about making AI faster, it's about teaching machines to think like humans. By merging structured knowledge with smart algorithms, we're unlocking a new era of reliable, adaptive AI. From self-driving cars to smart home systems, efficient planning is the backbone of automation. Next time you see a robot or app making a decision, remember, it's the result of clever planning, hidden logic, and a whole lot of problem solving. Thanks for watching. Drop a comment. What's one task you'd love to see automated? Let's keep the conversation going.